Welcome to the Eden Project. My name is Robbie and this is Mark, and today we're going to be looking at some of the ingenious adaptations that plants have evolved in order to cope with life in the rainforest. So what is an adaptation? Well, adaptations are features that animals and plants have that allow them to live successfully in their habitats. So as an example from the insect world, let's have a quick look at the honeybee. Firstly, the colouring of the bee. It's got these beautiful yellow and black stripes. Now it's thought that these stripes act as a warning to other animals to stay away. Now, as everyone knows, the bee has a stinger. This is used for protection, but the bee will only use a stinger if it feels itself or the hive is being threatened. Honeybees also have a fantastic adaptation for transporting pollen. On the outside of their hind legs, there is a hairless and concave pollen basket. The bee can press the pollen into this pollen basket, and in that way it can transport it back to the hive. So what are the biggest challenges for plants in the rainforest? Well, firstly, ensuring that future generations survive. This involves pollination, fertilisation, seed dispersal and the germination of seeds, each of which presents their own set of challenges. There are a whole host of pests and diseases that plants have to contend with in the rainforest. Being eaten and getting mould growing on your leaves must be prevented. There is also competition from other plants for resources such as nutrients and light. And lastly, it's not called the rainforest for nothing. There's a great deal of water about, and so avoiding waterlogging presents a significant challenge. So let's go and have a look at some of the clever adaptations that plants have developed to cope with this extreme environment. Welcome to the pitcher plant. No, not a picture of a plant, the pitcher plant. Soils in the rainforest are actually very poor in nutrients, but the pitcher plant has developed an ingenious adaptation to help it gain extra nutrients and survive. It attracts insects into the pitcher using nectar. However, once the insects are inside, they find it very hard to get out. This is because the walls are smooth and they're waxy. They end up in the fluid at the bottom of the pitcher. Now, this fluid is thought to contain microorganisms and enzymes which digest the insects, and then the plant absorbs those extra nutrients. Things that end up in the pitcher are usually invertebrates and small insects, but it has been reported that small rodents have even been found in these pitchers. Now, the next plant I want to show you is really popular with our visitors. That is, once they realise what it can do. Have a look and see what happens when I touch one of these leaves. Now, there's several theories as to why the plant does this. It may be a defence from herbivores, either because the plant looks less appetising once it's wilted, or the herbivores may be scared off by a fast-moving plant. It's also possible that the leaves closing up in this manner is protection against heavy tropical rainfall. Getting enough light for photosynthesis can be a real issue for rainforest plants, but there is a group of cheeky little plants that have found a way to get around this. They're called epiphytes. Now, epiphytes are plants which grow on other plants, like this one here. Now, they do this non-parasitically, so it means that this plant isn't actually damaging the tree that it's growing on. It does this so it can get further up and closer to the light. These epiphytes are able to get their moisture and nutrients from the air and the rainwater around them, and they're also able to get nutrients from debris which starts to accumulate around the plant. Epiphytes are the ultimate plant hitchhikers. So why might a person be wearing something like this? Well, apart from having absolutely no fashion sense, they'd probably be trying to attract the attention of others. In much the same way, flowers use bright coloured petals and scents to attract pollinators. At the end of the day, if the flowers don't get pollinated, then the plant won't be able to reproduce and the species won't survive. So this is vitally important. think he said tell us about mangroves. Now mangroves grow on tropical coasts with soft soils. They're an incredibly important ecosystem, offering a nursery ground for many species of fish. They also trap sediment that's been washed off the land that would otherwise smother coral reefs. In addition to that, they offer some protection during events such as tsunamis. However, there are some unique challenges for plants trying to survive in this habitat. First of all, they're going to be flooded by seawater each day, and the seawater will have a high salinity. They also have to deal with the actions of tides, winds and waves, and on top of that they have to deal with water and mud which can be very low in oxygen. Now in terms of dealing with salt, well, some species of mangroves are what we call salt excluders, and they actually filter out the salt from the water that's being absorbed by the roots. Some species are what we call salt excretors. These species push the salt into dead and dying leaves which eventually drop off the plant. So they're basically using those leaves like rubbish bags. And last but not least, mangroves have specially adapted roots. They have some which come down from the stem and go into the mud, and these act to stabilise the plant. These are called prop roots. And they also have pneumatophores. These come up from the roots underneath the mud and act like snorkels. Their function is to suck air down into the root system because oxygen levels in the mud can be extremely low. The traveller's plant is one of the most eye-catching plants that we have in our rainforest biome, and it's got some fairly obvious adaptations. Firstly, the leaves are huge. They're much bigger than me, and they act like giant solar panels, maximising the amount of sunlight that can be absorbed for photosynthesis. Also, in the wild, these leaves line up in an east-west direction, again to maximise sunlight absorption. Stores of water can also be found in the stems, but if you're a lost traveller, make sure you work out which way is east and west before you chop one of these stems down for a drink. The plants that we've seen today have taken millions of years to evolve the adaptations needed to survive in this extreme environment. They're unique and they're highly specialised for life here. The question is though, which plants will be the winners and losers as climates change, and what might be the knock-on effects for us humans?